Welcome back. In this lesson, we're going to be looking at an input device called a digital camera, and we'll discuss why it's required. Now, digital cameras are quite common. You see digital cameras in your smartphone, on your tablets, perhaps they're being used as a webcam on your laptop, or perhaps you have a DSLR, which allows you to take amateur or professional level photographs. So, what exactly is a digital camera? Well, a digital camera is an input device that captures images. It also captures video sometimes, but it does that digitally. Traditional camera uses film, and that film has to be exposed to light in a dark room to develop a photograph. Digital cameras don't need to do that. Because of that particular reason, they're really, really fast in developing photographs or capturing images. Digital cameras use an image sensor chip to capture the image rather than film that is used by traditional camera. The images recorded on a digital camera are stored on memory card, although some may have a limited amount of memory inside the camera itself. Now, digital cameras feature a screen which allows you to preview and then review the images. So you could delete them if you don't like them, or you can save them or store them if needed. Sometimes they also have basic editing software on the camera itself to change the exposure levels and the light levels and so on. So what are the typical applications for a digital camera? Well, they're used for professional photography or amateur photography. Now, amateur photography is basically you taking pictures on your own. It's a hobby rather than at a professional level. Of course, you can use them for webcams, and they can also be used for other applications like speed cameras, where you use optical character recognition software to detect number plates for speeding cars. Even autonomous cars are using cameras these days to record video and then decipher what's going on in a particular scene. So, what are the benefits of digital cameras? Well, images can be reviewed immediately by the screen, and these images can be copied or edited easily on a computer. Images can also be added automatically to sharing sites such as social networking sites without too much work. Of course, there are some drawbacks to digital cameras as well. You really need a good camera to match the quality of traditional film cameras. They can be quite expensive, especially if you buy high quality lenses, which allow more light in. Large capacity memory cards are needed if shooting lots of photos or high quality, high resolution photos. And of course, they need power, so battery packs can run out of charge, which isn't the case with traditional film cameras. Now, these type of cameras are controlled by an embedded system which can automatically carry out the following tasks. For example, embedded systems allow the adjustment of the shutter speed, they focus the image automatically, they operate the flash if there is one built in, or they allow control of an external one. They adjust the aperture size, so the hole through which light passes can be altered. They allow adjustment to the size of the image. They might have features like removing red eye, or more and more cameras have AI-based elements which allow changing the light level and the exposure level of a particular image. Now, modern digital cameras simply link to a computer system via USB port or by using Bluetooth or Wi-Fi. Phones have also caught up with digital cameras as regards to the number of pixels, but the drawbacks are that they often have inferior lens quality and limited memory for the storage of high resolution photos. This is changing very quickly though. Many smartphones have very sophisticated lenses, and photography software, often artificial intelligence, is used to enhance pictures taken by smartphones. So they're catching up to professional level cameras. However, just remember that a big lens will allow a lot more light in, whereas a small lens can only allow a limited amount of light in, and everything else has to be altered afterwards through software. So how does a digital camera work? Well, an image is captured via light, and that light is passed through a lens and onto something called a charge couple device or a CCD sensor array. Now, this converts that analog signal to a digital signal. So a digital representation of the image is created. There's a timing device that allows different shutter speeds, which allows delayed action, alters the aperture size to allow more light in, and things like that. So let's see how we can write this in words. This is the bit that you need to know for that exam, in addition to the applications, benefits, and drawback. So what happens when a photograph is taken? Well, light passes through a lens onto a light-sensitive cell. This cell is made out of millions of tiny sensors which act as photodiodes. Charge-coupled devices, CCDs, convert light into electricity, and these photodiodes are basically those things. Each of the sensors are often referred to as pixels since they are tiny components that make up an image, And this image is then converted into tiny electrical charges, which are then passed through an analog to digital converter to form a digital image array. The ADC converts the electrical charges from each pixel into levels of brightness. For example, an 8-bit ADC can give 256 possible brightness levels per pixel. And apart from brightness, the sensors also measure color, which produces another binary pattern. Most cameras use a 24-bit RGB system, red, green, blue system. Each pixel has 8 bits representing each of the 3 primary colors. The number of pixels determine the size of the file, which is used to store the photograph. Now, all you need to know here is the bits in bold. Light passes through lenses onto a light-sensitive cell. This image is then converted into an electrical representation via an ADC. And that probably will be enough to give you 4 marks. Now, there are a number of factors that can influence the quality of an image captured by a digital camera, and that depends on the camera itself, how good the camera's lens is, and how good the camera's sensor array is. Also, the number of pixels that you use, the more pixels you use, for example, a higher resolution image, the better the image quality will be, but the greater the file size will be. The levels of light that you use and how the image is stored. Are you going to store it as a JPEG, which is a compressed format, versus a RAW file, which is an uncompressed format? That can influence the quality of the image itself. And that's all there is to digital cameras. Hopefully you should be able to answer the following questions. You should be able to describe the operation of a digital camera. You should be able to list down the factors which influence the quality of the captured image. You should be able to give a couple of benefits of digital cameras, and you should be able to list 4 common tasks that a digital camera can do through the use of embedded systems. In addition to that, you should be able to list 2 applications of digital cameras apart from just using it to take pictures. Now, if you have trouble with any of these questions, please go through the video. The answers are in there somewhere, or you can get back to me. That's all for this particular lesson. I'll see you in the next one.